Alright, so let's take a look at the first part. So what did you guys get for your PPMC table here? What did you guys get for your critical value?
0.669.
No.
0.7, sorry.
0.754?
Yep. What am I doing?
And negative 0.754? And then your R was negative 0.944. So is it a line or not a line?
It's a line.
Yeah, we're going to reject H naught.
Thank you.
It's a line. Is a line. Which means I can use, we'll use y equals a plus bx. So then you got to go in and put these into your calculator. And what do you guys get for A?
102.49.
Yep, 102.5, and your B was?
Negative 3.62.
3.62. So you end up with y equals 102.5 minus 3.62x. Good? And then we wanted to know what happens okay, so 17 abscences. Are absences by x or by y?
X.
X. So I'm going to put in 17 for x and figure out what the y is. Did everybody do that yet?
Yes.
Right, so it says, approximate the grade. What's my grade? Is the grade the x or the y?
The Y.
Y. Approximate the y when the absence is, the x is 17. So when x is 17, what do you approximate what y should be? So everybody do that now. And what did you get?
40.95.
40.9. So that's your guess. So they get like a 41% roughly. Good?
Yes.
Now, what if R is 0.323? I know you guys have a lot of room, so you can put it right above. Where would it go if R is 3.23? We're up here.
It's not a line, so use.
Yeah, so it'd be right in here. You guys all follow me?
Yes.
So then this is not a line.
So it's Y bar.
So you, so then everybody figure out for me, find when x is 17, what should y be? Y equals what? It's not a line, so you're going to use what?
Y bar. Sample mean.
Use the average y. Everybody understand that?
Yep.
So everybody find the average y. You have the y already in a list. It's really easy to find it in a list.
One bar. Yes, L2.
So yeah, you already have it. So just do one bar stat of whatever list y is in, and that will give you your average. It'll call it x bar because it assumes everything. It calls everything x bar, right?
Yes.
You know you put y's in there, so you know it's really y bar. What did you guys get?
73.
Did everybody do it? Here's the other thing too. Because you have x's and y's, you could do two bar stats and put in L1 and L2, and then it will give you what the y bar is there too. You can do either one.
Or
But one bar stats is if you're, I'm sorry?
you could just do one bar stats on list 2.
Yeah, exactly. It's probably easier if you guys are more comfortable with that. One bar stats on whatever list you put your y's into. What did you guys get?
73.
73. Did everybody get 73?
Yes.
Good. Okay. The last part we're going to skip and save for later. Problem number 6, we'll do that. This problem, we'll do that next class. We probably need a little more review with this. But for right now, I want you guys to pull out your chapter 11 notes.
Ooh, chapter 11.
have them? You started today? Okay, Dennis, go ahead and read. Oh, actually, no, I was going to read it part. So it's in chapter 11. There are 3 different tests we're really going to look at in chapter 11. The first one we're looking at is goodness of fit, and that's what we're going to do today. So let's take a look at 11.1. Okay, so Dennis, go ahead and read now. Oh, so first of all, that CHI,
Chi. Yeah.
it's like, can you guys say the word kite, like flying a kite?
Kite.
Kite. It's chi, as in kite.
Kai.
Okay, so CHI is not chi, it's chi, like kite. Dennis, go.
The chi-square statistic can be used to see whether a frequency distribution fits a specific pattern. This is referred to as the chi-square goodness of fit test, which tests the claim that an observed frequency distribution fits some of the expected frequency distribution.
Good. So our H naught for these is always going to be that O sub I equals E sub I. In other words, what actually occurs is what I expect. What occurs is what I expect it to be. The sub I means that, it just means like the first one, the second one, the third one. So the first observed equals the first expected. The second observed equals the second one expected. The third one observed equals the third one's expected. And then H1 would be that O sub I does not equal E sub I. In other words, what actually occurs is not what you expected. Okay? In this case, our claim is pretty much always going to be H naught. We're always going to claim that it equals what we expect. So we're going to do the test to either reject or fail to reject our claim. Everybody on board with that part?
Yes.
Okay. Couple assumptions. Should be a random sample. My expected frequency for each category should be 5 or more. So these are frequencies. The last thing we did was means. So all of chapter 10 was means. And so those are going to be x's and y's. We found means for x's and y's, right? So those are all means. Chapter 11, 11.1 and 11.2 are all about frequencies. So they're about proportions kind of in a way. We have categories. So like eye color. We have blue eyes, you have green eyes, you have hazel eyes, you have brown eyes, right? So you have different categories. So those are going to be yeses and nos. Does that kind of make sense, sort of in a way? So it's going to be kind of more along those proportions. Here's some notation. Sean, go ahead and read.
Observed and expected frequencies. O represents the observed frequency of an outcome found by tabulating the sample data. E represents the expected frequency of an outcome found by assuming that the distribution is as claimed. K represents the number of different categories or outcomes.
So in other words, like, the different colors of eyes, how many options you have, number of categories you have.
N represents the total number of trials for observed sample values. Or,
Yep.
sorry, or
It's your sample size. Here's the formula for it. Chi squared. Okay, so again, this is not x squared. This is a chi. So it's a swooshy line like that, and a line straight like that. It's not an x, it's a chi. It's a Greek letter chi. Just accept it. The Greeks did it a long time ago. We can't change that. And then it's chi squared. So it doesn't mean that you take chi or x and you square it. It's just, that's the same, chi squared. I don't know why. I'll ask this guy in my 5 p.m. class because he kind of knows everything. He might know. But that's what we call it. It's called the chi-square distribution. So what you do is you take every observed value, subtract what you expect to get, you take that difference and you square it. And then you divide that by what you expected. You do that for every single one of your categories, and then you sum them, you add them all up. That's your chi-squared number. Your degrees of freedom is the number of categories minus 1. And K represents the number of different categories. So here is one thing. Let's get, Charmaine, you want to read?
Sure. Example, fruit soda flavors. A market analyst wished to see whether consumers have any preference among the 5 flavors of a new fruit soda. A sample of 100 people provided the following data. Is there enough evidence to reject the claim that there is no preference in the selection of fruit soda flavors? Using the data shown previously, let alpha equals 0.05. What are the expected values?
Great. Expected value. So if there is no preference, then what do I expect them, all the values in those categories to be?
Equals.
Equal to each other. Does that make sense? They should be the same. There's no preference. It should be like 5, 5, 5, 5, 5, or whatever. 10, 10, 10, 10, 10. So if I sample 100 people, and there are 5 categories, how many should be in each category?
20.
20. Do you guys understand why? I have 100 people. I have 5 categories. So your expected value should be the number of people you have divided by the number of categories you have. 100 divided by 5, so it's 20 in each. Everybody follow that part?
Yes.
Great. So then step 1, state the hypothesis, identify the claims. So these are your hypotheses, write them down. That's on your sheet, on your notes.
Is that a J or an I?
That's an I, O sub I, and E sub I. Yeah, those are I's. If you have time, then write in the observed values in there somewhere as well, because I think I neglected to write them on the paper. It's my fault. Okay, everybody have that first step down?
Yes.
Then we're going to find the critical value. We use the chi-squared table. So, what's my degrees of freedom, guys?
Categories minus 1. 4.
Yeah, categories are minus 1. How many categories do I have?
4. I mean 5.
So what's my degrees of freedom?
4.
Everybody on board? There are 5 categories: cherry, strawberry, orange, lime, grape. Subtract 1, because there's only one variable, right? The flavor of grape soda. So subtract 1, you get 4. So you guys pull out your chi-squared table. Show you guys real quick. The only ones you're really going to use are going to be these 3 circled ones. So you might want to just get a colored pen and circle those 3. We're only going to use when we have 10%, 5%, or 1%. These 3. Those are the ones we really care about.
Yay.
So 10%, 5%, 1%, you probably want to circle those up top. Of the chi-squared table that I handed out just a couple minutes ago. What's the one? Okay, and then we have our degrees of freedom is 4. So alpha is 0.05, degrees of freedom is 4. 9.488. You guys on board with me?
Yes.
Okay. So my degrees of freedom, I'm sorry, my critical value is 9.488. So this is how you draw a chi-squared. It goes kind of up, a steep hill, and then again it kind of tapers off like that. Look at the picture. And you see how it starts at 0 on the left? You guys see a picture of your little sheet here? Starts at 0 and then goes out. It's always going to be right-tailed, always. Because you start at 0 and you just go in one direction, up to infinity. So I'm just going to draw in here and shade, and it is 9.488. Then we're going to compute the test value. Okay, so my test value is going to be my chi-squared is equal to the sum of all these guys. I'm going to add them all up. Sum of my O sub i's minus my E sub i's squared over E. So that's going to be, my first one is my 32 minus my expected 20 squared over 20 plus, so you guys should be writing this down because you need to show your work, so you have to write these parts down. Incidentally, on the test, it's only going to be like 3. I'm not going to give you 5. I'm only going to give you like 3. So it's not going to take you forever to write them down.
Thanks.
Plus 16 minus 20 squared over 20 plus 14 minus 20. Do you guys all see where I'm getting these from?
Yes.
Over 20, and the last one is, it's like 10 minus 20 squared over 20. Okay, now, how to calculate it. Let's do it the easy, lazy way.
What's the last one?
Yeah, so let's use our lists. So here, go to your calculator. Stat, edit. And I'm going to clear out my list. I'm going to go up to L1, so I'm actually in L1 and hit clear enter to get rid of that. And then go over to list 1, go where I'm actually up on L1. I'm in the, the L1 is dark, clear enter. And then I'm going to put these in. So what were they? They were 32, 28, 16, 14, and 10, which makes no sense because grape soda is awesome. I don't know why, but still, I like it more. And these are all 20. 20, 20, 20, 20, 20. Okay. Here they are again, if you can't see them. They're right up top. You can't see them right now. So they're right up top up here. 32, 28, 16, 14, and 10. And then all the expecteds are 20s. Good so far? Moving on? Okay. So here I have them. I have the observeds in my list 1. I have my expecteds in list 2. And then what do I want? I want my observed minus my expected squared divided by my expecteds. So I'm going to go, so I'm actually on the L3. So you see how my cursor is actually on the L3? It's dark there. And I want observed minus expected. So I'm going to put parentheses. What's my observed? Where are my observeds?
L1.
L1, second L1, minus, where are my expecteds?
L2.
L2, second L2, close parentheses, and I need to square that. So raise to the second power. And I need to divide all of it by my expecteds. So divided by, what's my expected?
20.
Yep, L2.
L2.
So second L2.
Okay.
When I hit enter, all these will come out where they're supposed to be. Boom, just like that.
Nice.
Good? Okay. All right. So we'll go ahead and do that. And then I need to add them up. So how do I add these guys up? Stat, Calc, 1 bar stats of which list?
L3.
L3, second L3. And that will give me the sum of them. If I look at my sum of my x's, it's 18. Good? This is also written down in your notes, I believe. Maybe not.
So it's 18.
Oh, it's written in my notes, sorry. I'll write it in here. You can also do your observed into list L1, your expected into L2, and then you're going to have L3 is equal to parentheses L1 minus L2 and parentheses squared divided by L2. And then your chi-squared will be your sum of your list 3. Good? Okay. So now you're looking at kilo points, and that's not there. Okay. So there's your, here it is a little bit quicker, how to find it like that.
Uh-huh.
And then here it is nicer and neater using your calculator. That's okay. You're killing me with this points. Okay.
I'm losing.
Well, you are lost a couple. She lost one. Okay. And then, let's take a look. Where does this go? Where does this 18 go in this picture? You're way over here. Everybody on board? So are we going to reject or not reject H naught?
Reject.
Yeah. So step 4 will be reject H naught. And then step 5 is like this. Enough evidence to reject.
Yep.
Because remember, H naught's going to, pretty much always are playing with these. That fits some expected values that we have. To reject claim that,
there is
or of,
there is no preference.
yep, that there's no preference. I just put of no preference because I'm lazy. Of no preference in soda flavors.
Yep.
Good?
Yes.
So then this is them doing it prettier. Oops. I probably should have put that one later. All right. Does that sort of make sense for folks?
Yes.
So our expected frequencies, if the expected frequencies are not equal, then there's always going to be stated the problem. And then your expected values will be n times whatever the probability is for that part. If the expected frequencies are equal, then it's just going to be whatever your n is divided by k, the number of categories. So you're going to take your n, the number of people, and split them up equally into categories. Your observed is what you actually observed. So those have to be whole numbers, because it's what you actually got in your survey. The observed is from your survey. The expecteds can be decimals. You can expect to have 2.4 children, but you can never actually have 2.4 children. Does everybody understand what I'm saying?
Yes.
Okay, so your expected can be decimals. So say I flip a coin 5 times. What are my categories if I flip a coin? What can I get?
Heads or tails?
Heads or
or
tails?
Right. What's my K?
2.
Two categories. Probably getting a heads is 0.5, tails is 0.5. How many heads do you expect to get if I flip it 5 times?
2.5.
Yeah, my expected value is equal to n times p. Right, you guys are familiar with that, NP, that's always your expected values for these things, for binomials. So it's n 5 times 0.5, 2.5. How many tails?
2.5.
2.5. So again, remember those expected frequencies do not have to be whole numbers. If I flip a coin 5 times, I expect to get 2.5 heads and 2.5 tails on average. Good? But you're never going to actually flip a coin and get 2.5 heads. Your observes have to be whole numbers. Good? Okay. I want to go over a little bit our project. Let's take a look at that. So the final part of your project, correlation and regression, has to be done in Excel. There is one other thing I think someone said that it can be done and that's free, but I don't remember what it was. Google Sheets won't work. Google Sheets does not have the stuff you need in order to do it.
I think on the library website, it has like Word doc and it has Excel. You can download it.
Okay, cool. Good deal.
Get it for free too, just for having your student ID.
You can get it for free using your student ID?
Like your login, your email login.
Really? Okay, good deal. So you can, is that like Microsoft 365 or something like that?
Yeah.
Okay, cool. And also, all the computers on campus, all of them have Excel, all of them. Okay, so we're going to use it to create a scatter plot, and including a regression line and equation of the scatter plot. Including regression line and the equation on the scatter plot. Test to see if there's a correlation between your quantitative data sets. So you picked 2 numerical data sets at the beginning of the class. And it might be like age and height or something else. If you have ones that totally, that don't work for some reason, you can email me and we can talk about it and I can see if you need to switch to something else. But pretty much everybody should be okay with that. You picked 2 numerical ones in the beginning. You want to see if they have any sort of correlation. So you're going to write down what those 2 were. I have written down what all of yours were, so don't go making up something else. You all took a picture of it at the beginning of the semester, so go back to that and find them. And then pick one that will treat as your X. In other words, which one do you think you have more control over? So if it's age and height, which one do you think you kind of control more, your age or your height?
Your age.
Age. You probably use age then. Does that, you might say that age might explain your height more than vice versa. So you probably put age in there. Then, pick a value for X that you'd like to predict for Y. So maybe I might want to say, oh, well, how tall will I be when I'm age 40 or something like that? Right? So pick a value for X. Whatever you want. If you want to know when your age is 40, you pick X is 40. And then circle it, because you're going to need to use it later. You need to be able to find it later on when you need it in the end of towards the later part of this lab. What's your initial impression of the data? In other words, do you think there's going to be a linear correlation or not? Do you think that age and height are related or not so much or whatever? And then go to our class survey data online, if you have messed with yours at all, and copy those 2 columns over. So use Control-C to copy it, open a new Excel sheet, and use Control-V to paste it in there. And paste them in next to each other. It's really, really important that you keep each column in order. So each row, like this person who's 19 goes with 2 classes. This person who's 20 goes with 3. If you start messing with these this order, then they're not going to be going to the right spot. It should be the same person. Also, see how this one has a blank there? Then you just delete that one also, so that it's both of them are blank. All on board? They both have to have numbers in them. If not, then delete the other one so that they're both blank. Then we're going to find slope. So this column over here, you're just going to type in the words like R equals with parentheses around it in here. So then you'll have the R equals and the number will be in this spot here. So then here you'll type in equals Corel parentheses, and then you're going to grab both of your columns. So it's going to be B1 to B160, comma, C2 to C160, or whatever yours is. Everybody sort of know that part? So this would be Corel parentheses, and then grab your first part, and put comma, and then grab your second one. And that will give you the correlation coefficient. That will give you your R. The one below that, you need to find your slope, your B. So you're going to type equals slope in there, and you're going to do the same thing. And then you want to find your intercept, your A. Wait. A plus BX, your A. Yep. So you're going to type that in there. And then you want to find the average of each one, because you might need those later on. And then you're going to make a scatter plot. So you're going to highlight your 2 columns of data, just like this down here. Insert, scatter, that first one there with the little dots around it. And then change your chart title to your X variable name versus your Y variable name, like example age versus height or something like that. To add a regression line, you right click on any point in the scatter plot, so I just would right click on one of them, and then it'll give you a pop-up menu and pick trend line options, choose linear, and then if you have a different version of Excel, then that may not come up. So you do chart tools and layout, and then find trend lines in there and more trend line options. So you should end up with this at any rate. And then it says, check the box that says display equation on chart right here, and display the R squared value on the chart. So put those 2 bottom ones there where you show those. And then you'll see them popping on there. They should match up with what you found. Print out 2 copies of it. So print out 1 copy with the numbers in it, and then print out a separate copy with the formulas in it. So if you go to show formulas, it will show the actual formulas, like equals Corel versus the actual number. You guys understand what I'm saying? So the correlation might be 0.732. I also want to see the actual formula where it says equals Corel parentheses B2 colon B160 comma C2 colon C160. I don't need the data. I just need those 2 printouts of the pictures and
The formula.
the formula. So the bottom part. You can just print. You don't have to print all your data. Just select the parts shown above, and when you print, you choose print selection, and that'll just print the parts you need. And then do a correlation test. So do the whole correlation test like you've done before. You found R, so you don't need to find R. You put all your data in your calculator. You've already found your R. But figure out what your critical value should be. Draw your picture. Put in R where it belongs, and then reject or not reject, all that other stuff. And then, based upon if you rejected H naught, then with your X value, write in what your X value is, and you're going to predict the Y value using, if you reject H naught, you'll use your linear regression line. If you do not reject H naught, then you're going to use your Y bar. Good?
Yes.
All right. Pretty straightforward. Good.
And then just this part is reversed, so it would be BX plus A.
Oh yeah, right. So remember the Excel. So Zachary pointed out something interesting, that you guys are used to A plus BX. Excel does it the opposite way. It does the bx plus a thing. It does it the other way around. It does it y equals slope times x plus the intercept. And if you look on, it'll give you on your screen, your scatter plot, it'll give you the formula, so you can look at it there too. But just something to keep note of.
You saved the whole project for me.